Have you ever wished your software applications could just tell each other when something important happens, instead of constantly having to ask? Imagine a world where your online store instantly knows when a payment is processed, or your project management tool updates the moment a task is completed, all without you lifting a finger. That proactive, real-time communication is exactly what a webhook provides in API interactions. At its heart, a webhook is an automated message sent from one application to another when a specific, predefined event occurs, essentially pushing critical updates the moment they happen. To truly grasp webhooks, let's contrast them with the traditional API approach, known as polling. In polling, your application repeatedly sends requests to a server, essentially asking, "Hey, anything new yet?" This is like constantly checking your mailbox for a letter that might not even be there. It's often inefficient, consuming resources on both sides, and introduces delays because updates are only discovered at the next check interval. Webhooks elegantly solve this by reversing the communication flow. Instead of you polling the service notifies you. Your application provides a unique uniform resource locator, or URL, which acts as a dedicated delivery address. When an event you're interested in takes place, say a new customer signs up or an order status changes, the source application triggers an HTTP POST request. This request is sent directly to your registered URL, carrying a data payload that describes the event. This event-driven mechanism means your application only springs into action when there's actual, relevant information to process, dramatically improving efficiency and enabling truly reactive systems. It's a fundamental shift from a request-response model to a notification model for specific events. Implementing a webhook receiver involves a few key steps. First, you'll set up a specific endpoint, a publicly accessible URL on your server, that is designed to receive these incoming HTTP POST requests. This endpoint will act as the listener. Second, you configure the external service you're integrating with, telling it which events you want to be notified about, and providing your designated URL. Once a webhook is triggered and the data payload arrives at your endpoint, your application then processes this information. This might involve updating a database, sending an email, or triggering another workflow, all based on the event that just occurred. For developers building robust and secure integrations, there are important considerations beyond just receiving the data. For instance, ensuring the authenticity and integrity of incoming webhook messages is crucial. This is often achieved through signature verification, where the sender includes a cryptographic signature in the message header, which your application can then use to confirm the payload hasn't been tampered with and truly originated from the expected source, using a shared secret. Another advanced concept is designing your webhook handlers to be idempotent. This means that processing the same webhook event multiple times will produce the exact same outcome as processing it once, preventing issues if a webhook is accidentally delivered more than one time due to network retries. Ultimately, webhooks empower developers to build for more dynamic, responsive, and interconnected applications. By moving from a constant checking paradigm to an instant notification system, they streamline workflows, reduce system overhead, and enable real-time reactions to critical business events. This sophisticated, event-driven approach is a cornerstone of modern distributed systems, allowing services to communicate seamlessly and efficiently, keeping everything perfectly in sync and delivering a superior user experience.
If this helps you code smarter, like, subscribe, and stay tuned for more.